So since each one of these cubes carries a bit of energy, if we can figure out how many of these cubes per second are flowing through this windmill, we can figure out how much energy per second is flowing through. Let's remember the definition of power. Power is energy per time. So this is basically joules per second. And for us, if we know the volume per second going through there, then we can figure out the amount of energy per second because we have a sense of how much energy per cubic meter there is in the wind. So let's actually think about, a joule would be how much energy there is per cubic meter. Actually, joules per cubic meter times cubic meters per second. This we know. We know how much energy there is per cubic meter. We've answered it in part A. So the question is, how much volume per how much volume per second is flowing through there? How much volume flows through this is, you can imagine this cross-sectional area, the area of this windmill scooping up air, and the air flows through it. So let's say in 1 second, how much air flows through it is its cross-sectional area times the velocity times 1 second. So what's the area of this? This is pi r squared. We know what the radius is. Pi r squared. And what's its velocity? We know its velocity. We're given it. So this meters cubed per second is actually equal to square meters times meters per second. This is a velocity, this is an area, this is our energy density. So how much power these things produce is equal to the answer of part A, which is the kinetic energy per meters cubed. You know this is a number. Watch the units. The area of this is from part A. The area of the windmill is pi r squared times the velocity you're given. If you keep all of those units, you'll recognize the meters cubed will cancel out. You'll just have joules per second, and that's equal to the power. Why does that make sense? Each cube of air carries so much energy. How many cubes pass through the windmill? It's a function of how big the windmill is and how fast the wind is blowing. There's velocity. Now your final answer has to be reduced by this percentage, 0.35, because only in my question 35% of the energy is taken out of the air. All right, try that.